In the previous video, I introduced you to the idea of free fall motion. A free-falling object is an object which is acted on only by the gravitational force and not air resistance or other forces. In that video, we studied the motion of falling objects such as the tennis ball or the tape dispenser, whose motion is pretty close to being free fall motion, at least between the time of release and the time they get to the tabletop. So even though that motion right there is pretty close to being free fall motion, what exactly is the tennis ball doing after I release it? It's hard to tell, right? Is the tennis ball immediately going to some fast speed and just maintaining that all the way down? Is the tennis ball going in little fits and starts, start, stop, start, stop, start, stop, start, stop, like that, except too fast for us to see it? It all just happens too fast to really see what's going on. However, there's a way where we can slow this down and actually get an idea of what's happening, right? What I can do is, instead of just dropping the tennis ball, I can roll the tennis ball down the ramp. And if I roll the tennis ball down this ramp, hopefully that will slow things down enough that we can kind of get an idea of what's happening. Okay. So I hope you could see in that experiment that as the tennis ball rolled down the ramp, it was gradually picking up speed. In other words, as the tennis ball rolled down the ramp, it was accelerating. Okay. Now let's say I make the ramp a little steeper. And I hope you can see that time that the tennis ball was accelerating again, except the acceleration was greater than when the ramp was more gradual. Okay. Now let's see. Now let's say I make the ramp steeper still. Right. The tennis ball still accelerates, but now the acceleration is greater. And the steeper I make the ramp, the greater the acceleration. Now let's say that I make the ramp completely vertical. Again, it's hard to see what's going on exactly because it all happens too fast. But if we can see the tennis ball gradually accelerate down a gradual ramp and accelerate more rapidly down a steeper ramp, and so forth, doesn't it at least seem reasonable that when the tennis ball goes down a vertical ramp, it is accelerating as well? And isn't going down a vertical ramp kind of like just falling right out of my hand? Right? So if we can believe that a tennis ball is accelerating or picking up speed as it goes down the ramp, it seems reasonable to infer that if I just release the tennis ball from my hand, it is accelerating or picking up speed on the way down as well. In class, we're going to do an experiment where we not only show that the tennis ball is accelerating, but we're going to be able to show that the acceleration is constant. And we're going to be able to measure what the value of that constant acceleration is. Now, in the next few videos, we're going to start doing example problems involving objects which are free-falling near the Earth's surface. And for those example problems, we're going to need the value of the acceleration of an object which is free-falling near the Earth's surface. So I'm going to go ahead and give that value to you. So here I'm giving you the numerical value for the constant downward acceleration of an object free-falling near the Earth's surface. An object free-falling near the Earth's surface accelerates downward at a constant rate of 9.8 meters per second per second. That rate is generally denoted lowercase g. We refer to lowercase g as the free fall acceleration. And starting with the next video, we're going to be doing some example problems which use this constant value of the free fall acceleration near the Earth's surface.